We have uncovered a remarkable planet, a world of extreme weather, alien landscapes, and bizarre phenomena. It's the most complex system we know of in the universe. That planet is Earth, and we are only beginning to unlock its secrets. The planet Earth is a haven for life.
Conditions are perfect. I mean, they really are perfect.
Oceans of liquid water make life possible.
But that's not enough.
A complex secret gives Earth its life, while hundreds of other known planets fall short.
Not a single one of these planets look just like the Earth.
What makes Earth so perfect? Why does it depend on the moon, volcanoes, even the planet Jupiter? What puts Earth in the ultimate Goldilocks zone for life? On Secrets of the Earth. May 19, 2012. In the Arizona desert, a 35-year-old visitor from Germany is overcome by 105-degree temperatures. The first of 2 hikers to die this weekend from early season heat. Water makes up 60% of the human body.
As little as 2 to 3% decrease in body water can onset the symptoms of dehydration.
Humans on Earth exist on a knife's edge between life and death, surviving only in a narrow range of temperatures. So too, in the solar system, there is only a narrow range in which planets can support complex life. This place, not too hot, not too cold, is called the Goldilocks zone. Estimates put the Goldilocks zone between 67 million and 279 million miles from the sun. And it's just right for the one thing life seems to need: liquid water.
You're not so close that water boils away. You're not so far away that water turns to ice. Perfect, Goldilocks.
We're in the Kau Desert on the island of Hawaii. When you look at dry places like this, it really makes you appreciate how vital water is to animals and plants.
Hawaii's Big Island is also home to rainforests, waterfalls, seacoast, and even snow-capped mountains, where the secrets of life's success on Earth play out. Among those secrets, a recipe for life that needs far more than just liquid water.
One of the biggest surprises of the last 20 years is the large number of conditions the Earth needs to maintain its state as being habitable.
Besides Earth's distance from the sun, life also depends on the planet's volcanoes, its large moon, and even the planet Jupiter. Liquid water is important, but that's possible at a wide range of temperatures, not all of them good for life.
The highest temperature that complex life can live at is very, very different from that of microbes. We animals really can't live much above 113 to 115 degrees Fahrenheit.
The Nahuku rainforest on Hawaii is a Goldilocks zone on a Goldilocks planet.
There are more species packed around me right now than any other place I could go to.
This rainforest and others like it represent the apex of species diversity on planet Earth. The diversity springs from conditions that are not only wet, but also warm without being too hot.
Life likes to be warm. 70 to 80 to 90 degrees, that's ideal. That's where you want to be.
The Earth's volcanoes hold the secret of the planetary thermostat. If it weren't for these mountains of fire, this entire planet would freeze. January 3rd, 1983. Hawaii's Kilauea volcano begins its longest eruption in recorded history as lava flows through residential areas.
The first homes destroyed there were 16 homes shortly after that initial eruption. A vivid reminder of the destructive power of the volcano.
The volcano's fury fuels mankind's fear. But the erupting mountains hold a secret. They are essential to life and play a central role in making Earth a Goldilocks planet. Volcanoes are commonplace in the solar system. They have erupted on Mars, on Jupiter's moon Io, and may number in the thousands on Venus. But unlike other planets, Earth's volcanoes are coupled to plate tectonics, the planet's method of resurfacing its crust. Earth is the only known planet whose crust actively moves around with many distinct plates. Many scientists now believe plate tectonics is the most important secret, other than water, in making Earth just right for life. It all has to do with carbon dioxide. Right now, it may be making the planet too warm, but life actually needs some of that warming. Without CO2, the Earth would be very cold.
It would be 0 degrees Fahrenheit, 32 degrees below freezing. Without that carbon dioxide, the entire planet would be a frozen wasteland.
The CO2 emerges from Earth's volcanoes along with their destructive lava. The essential gas cycles both in and out of the atmosphere, acting like a thermostat to keep the planet not too hot, not too cold. It may be one of the best-kept secrets of Earth's existence, a series of interconnected reactions that puts the entire planet to work, a chain of events in which one weak link would make life as we know it impossible. Fiery volcanoes seem unlikely players in the drama that makes Earth so perfect for life. And yet, without them, the planet would be covered with ice, and life would have little chance of success. The secret is in the carbon dioxide that volcanoes supply to the planet's atmosphere.
The volcanic vent you see here is one of many in the Hawaiian Islands. It's from vents like these that carbon dioxide comes out of the deep Earth and goes into the Earth's atmosphere.
As a greenhouse gas, CO2 turns Earth's temperature up. But in doing so, it becomes the core component of the planetary thermostat. It is a delicate global balancing act. If the temperature is cool, the planet makes carbon dioxide go up, so the air gets warmer. If the air gets warmer, the planet makes carbon dioxide go down to turn things cooler. One way a hotter Earth makes CO2 go down is by ramping up the chemical weathering of rocks. Carbon dioxide mixed with rainwater turns into a weak acid that eats away at Earth's rocks. When temperatures go up, the process naturally goes faster. The acid reactions absorb carbon dioxide and suck it out of the air. Earth's weathered rocks get help from another process to draw down carbon dioxide in the atmosphere.
More heat also speeds up the growth of untold numbers of plants and animals in the ocean. Many of these draw carbon dioxide right out of the air and use it to make their shells. All of these shells slowly sink onto the sea bottom to produce a limestone layer on the seafloor.
With both the formation of seashells and the weathered rocks, carbon dioxide dips down in the atmosphere. If it goes too far, the planet could freeze. So it needs a way to make CO2 go back up. That happens deep underwater. In the middle of the ocean, massive ridges on the seabed erupt with lava as plate tectonics drives the motion of the Earth's crust, making the ocean floor spread apart. Miles away, the spreading sea floor crashes into a continental plate. The sea plate dives down into the Earth's interior. The limestone melts, liberating its carbon dioxide.
The carbon dioxide that was set free underground eventually comes out here, back where we started at a volcanic vent. So now the Earth becomes warmer and the cycle begins again.
The finely tuned system has adjusted the atmosphere's carbon dioxide up and down to keep the Goldilocks zone on Earth intact for billions of years. Plate tectonics also makes Earth's land surfaces move. The giant Pacific plate, for instance, slowly moves to the northwest and carries with it the big island of Hawaii.
I like to think of the ground beneath my feet as stable, but geologically speaking, we're in constant motion. Right where I'm standing on the mountain of Kilauea, I'm moving 2 to 4 inches a year annually north-northwest. So if you came back to see me next year, I wouldn't be here. I'd be here.
When continents move apart, species are isolated and evolve into new ones. Life's wild variety grows. The complex diversity is an essential survival tool, especially when Earth comes under attack from outer space. The secret ingredients for thriving life abound on planet Earth. But its wealth of rich climates is also home to environments on the edge of habitability. One of them is Mauna Kea, an inactive volcano on the big island of Hawaii. It's an alien landscape, home to a dozen giant telescopes. But at high altitude, astronomers are working on the margins of the Goldilocks zone for humans.
I've been up here at 13,500 feet many times, and sometimes I feel a little bit of altitude sickness. My head isn't working right. I feel nauseous. The oxygen content up here is only about 60% that of sea level.
Astronomers here have discovered that the recipe for life's success on Earth includes many ingredients from space. The moon, unusually large for a planet of Earth's size, has a secret impact on life.
It provides stability for Earth's axis of rotation.
The pull of the moon's gravity keeps the Earth from wobbling uncontrollably.
Without our moon, we'd be flopping around like a dead fish. This isn't stability. Life needs two things. It needs conditions to live, but it needs those conditions to exist over long periods of time. You need conditions to remain very, very stable.
Having a large moon is part of the secret. But stability also comes from unlikely sources.
Many people are astonished to learn that the planet Jupiter, 500 million miles away, has a huge effect on life on Earth.
A major impact was a rare event on Earth when an asteroid may have wiped out the dinosaurs 65 million years ago. It remains rare today because Jupiter acts as a cosmic vacuum cleaner, as the planet's overwhelming gravity grabs comets and asteroids, sweeping them out of the solar system.
Jupiter, in our lifetime, swept a comet right out of existence. Shoemaker-Levy 9 went crashing into Jupiter. That particular comet was on an Earth-crossing orbit. Jupiter sucked it out of existence.
If you do not have a gigantic Jupiter, the solar system will be full of debris that would hit the Earth all the time, meaning that life would be impossible. So thank you, Jupiter, for cleaning out the solar system.
Earth's astronomers are now engaged in one of history's greatest quests, a search for other planets suitable for life. In early 2013, they identified a possible planet more like Earth than any yet found. At 2,070 light-years distant, it is 1.5 times Earth's mass and orbits within its star's Goldilocks zone.
There's thought to be about 50 billion planets in our Milky Way galaxy, of which perhaps 500 million are in the habitable zone. But that's not enough.
Mars, for instance, is in the habitable zone, but its weak gravity and irregular magnetic field left it unable to hold onto most of its atmosphere. Future outgassing might reverse the process, but today it cannot support complex life. It also turns out that the Goldilocks zone for any such planet doesn't last forever. Even Earth's time as a just right planet may run out sooner than you think. Planet Earth's secret set of special factors make it perfect for life. Most important, its place around the sun in the Goldilocks zone.
A planet is said to be in the Goldilocks zone when its distance from the star that it orbits leads to temperatures that allow liquid water to exist on its surface.
But the deepest secret of Earth's Goldilocks existence is not one of place and temperature. It is one of time. For complex life to evolve, Goldilocks temperatures must remain stable for long periods.
We have been in what we call the habitable zone now since the formation of life on Earth at least 4 billion years ago.
And that depends on a sun that does not burn out quickly.
If the sun were a gigantic star, it would burn its hydrogen very rapidly and only last for maybe 1 billion years or so. And that's too short to get life off the ground.
But even a long-lived star like Earth's sun changes over time. And so does its Goldilocks zone.
As our sun burns its fuel, in fact, it gives off more and more heat. It's actually going to expand.
Although a hotter sun could incinerate complex life, there's a secret killer that may strike millions, perhaps 1 billion years sooner. Today, carbon dioxide is temporarily on the rise, making the Earth too warm. But in the long term, the mechanisms that take it out of the atmosphere will dominate, making CO2 gradually disappear.
We can predict that perhaps in as little as 1 billion years from now, there will no longer be enough carbon dioxide for plants to undertake photosynthesis. When that happens, we very rapidly lose oxygen in our atmosphere. And when that happens, that spells the end of all animals on planet Earth.
But would the increased heat from the sun result in new Goldilocks zones, migrating into more distant parts of the solar system?
It could be that Mars will become temporarily habitable. Or maybe one of the moons of Jupiter or Saturn that has an icy crust will have liquid water on its surface.
Life's future will be at stake. While microbes may survive the extreme conditions on a superheated Earth, could its intelligent life forms escape to seek refuge elsewhere? If identical conditions aren't found, will successor worlds be good enough? Can they evolve their own set of factors that have made the success of complex life one of the greatest secrets of the Earth?